Welcome to series of conceptual classes on organic chemistry. It is the continuation of class number 4. Today I am going to discuss about the chapter amine, the left out part. In my last class, class 4, reactivity part, I did reactivity part and I started just amine as base, and here I told you that there are two things. One is basicity of these two. I told you in my last class that basicity of this one is more than that amine because of plus I effect. That means plus I effect, that is inductive effect, plus I group increases basicity because it pumps electron to amine group, so this pair becomes easily available for bonding. Hence methylamine is more basic than this. Now, if you talk about the in ammonia, there is substitution of alkyl group. So, substituted parts are this. This is 1 degree, 2 degree, 3 degree. If I now tell the basicity, to tell you the increasing or decreasing basicity order, again more the plus I group, more is the basicity. Because here CH3 does not have any steric hindrance, no steric hindrance of steric effect or steric hindrance of CH3. So this is the order. This is the order in gaseous phase. Whenever you take this same reagent, same compounds in aqueous phase, then the basicity will reverse. When it is in aqueous, when it is in gaseous phase, plus I effect take parts. But when these same things are in gaseous, not in gaseous but in aqueous, then solvation effect comes. Last day I told you solvation. So I told you more the number of H, more is the solvation, more is the stability of alkyl substituted ammonium cation, and more is the basicity. So here hydrogen is 2, hydrogen is 1, hydrogen nil. So more is the hydrogen, more is the basicity, more is the stability. So here 1 degree will be more stable than 2 degree will be more stable than 3 degree. Due to solvation effect in aqueous solution. In aqueous solution basicity is 1 and in gaseous phase basicity is plus I. Plus I effect influence the basicity in. Sorry for inconvenience. Amid the class, due to some technical problem, the class closed. Again from second part I am starting. Steric effect on basicity means in the first portion just now I have told that 1 degree, 2 degree, 3 degree, when alkyl groups are there, CH3 group is there. So as plus I groups increases, basicity increases in gaseous phase. But if in place of alkyl, methyl, if you use ethyl groups, it is a bit bulkier than methyl groups, then that steric effect comes into play. So this is 1 degree, this is 2 degree, this is 3 degree. So as a rule, more the plus I effect, more is the basicity, but due to steric effect of bulky group C2H5, here 3 degree will not be as such more basic, 2 degree will be higher than 3 degree than 1 degree. So this is all about the basicity of amine in aqueous solution or in the first part, first reaction was alkenes base, and second was the reaction of alkylation, third one acylation, carbylamine with nitrous acid, with Grignard reagent, with Hinsberg reagent, and coupling reaction. So first part alkylation, we have done it, ammonolysis, alkyl groups, ammonolysis. We have done it earlier. Now number 2 is acylation. Acylation. So here in base, preferably pyridine, or sometimes it is sodium hydroxide is used. So this lone pair acts as nucleophile ataxia. C2H5 and that bond role. So this is plus, it is unstable, deprotonation occurs. In presence of base, this bond will turn downwards, and here this moves away. One of the important thing, the use of pyridine or base sodium hydroxide. What is the function of this thing? Means in the reaction, HCl comes out. So that acid reacts with base and it diminishes the action of hydrochloric acid further in the reaction. This is the function of pyridine. So in the moment I recall that in NEET 2023 question asks how many sigma pi bond and lone pairs are there in pyridine. So maximum of the student answered wrong. Sigma and pi bond you can very easily calculate it. Sigma bond you can very easily calculate it. This is sigma, 6, 6, and like this you can calculate. But maximum of you have forgotten this lone pair. Mind that due to the presence of this lone pair, it is base. Next one is very important for exam, carbylamine reaction, CH3, NH2, we have seen methylamine or amine, 1 degree amine, any amine, ethylamine, any 1 degree amine reacts in presence of chlorophenol and potassium hydroxide will get isocyanate. Isocyanate, and this is fishy, foul smelling compound. You can very easily detect the compound. So question comes in exam is that what type of amine reacts with chlorophenol potassium hydroxide or respond to carboylin reaction? Answer is 1 degree aliphatic and or aromatic. Both 1 degree aliphatic or aromatic amine react to give isocyanate compound. Next one is with Grignard sorry, HNO2, nitrous acid, which can be obtained from sodium nitrite plus HCl during the reaction, and it is in situ preparation. I told you earlier. HNO2 and NaCl. You get this one. So nitrous acid very easily reacts with amine to give diazonium salt, alkyl diazonium salt, and when it made to react with water, it gives alcohol. It's a very important one. Every later I am coming to diazonium salt, and if it is arylamine, same nitrous, answer N2, water a bit warm, phenol. So that is how nitrous acid reacts with amine. Coupling reaction is para-hydroxy azobenzene. Its color is orange in exam. The question comes para-hydroxy azobenzene. What is the color of this compound? It is orange. And another type of same type of reaction, you use the same thing and you just use amine here. The compound will be para-amino. This group is azo. It is very important group, and for the group of this azo, it is used extensively in the industry. Para-amino azobenzene. Its color is yellow, but sometimes in exam yellow option is not given. It is not given, you can write it. The last part of this reaction is with Grignard reagent. with Grignard reagent. Say this is amine, and let me use a Grignard reagent like this. So very simple, this reaction is very simple one. These parts combines to give you alkane, and if it is CN and Grignard reagent say C6H5 MgBr, what product you will get? Maybe minus and it is with plus. Earlier I have mentioned you, this is minus and this is plus, am I right? So here you are getting CH3, C double bond, and negative part comes to plus part, C2, H5, and Mg, Br, then acid hydrolysis, the reaction is, mechanism is hard, but we will get CCH3, I'm mistaken, this part comes here, am I right? CH3, C is plus, negative parts comes here, and MgBr, am I right? So whole part get removed as ammonia like this. Critical mechanism we have, you just add up O, CH3, C double bond O, C2H5. So this is about the type of the reaction shown by amine. Now let us explain the second type of the reaction, electrophilic substitution reaction. You are quite accustomed, or it is known to you all, that aromatic compound, aromatic substance very easily undergo substitution reaction, electrophilic substitution reaction, and since we are dealing with amine, we will first explain ammonia. So in earlier class I have already shown that ammonia is activating group only because of the fact that this lone pair involves in resonance, and in its withdraws electron, and minus comes instantly in these positions, and electrophile comes here and hydrogen get removed, so electrophilic substitution very easily occurs. Because of activating group of NH2 in benzene ring, so what's happened, if you give water in aqueous, so instantly, bromine in aqueous, instantly what happens, we get this compound. 2,4,6 tribromoaniline. It is white PPT compound. It is white PPT is there. And if you use another things, it is carbon disulfide, then you will get ortho and para in separate way. And first there you have got it. Now the problem encountered here is, if you want to get, say this is amine, if I ask you to prepare para-amine only, major product, major. So So you will encounter a lot of difficulty to convert this one. You can't find out. Only when you can convert this, when the activity of this group is checked. By checking the activity of this group, if we continue the reaction, then we can get para-bromo aniline compound. So how can you do this? We will first do acylation. Am I right? So what happens when you use this group? So instantly that will enter, replacing one hydrogen, this groups enter cell. When these groups enter cell, the activity of this group NH2, activity of earlier NH2 group reduces. I'll show you how. And now if you use bromine in acid, you will get bromine in this position, and on final step these groups becomes this, you will get this one. Now come to this part. What happens to this one? When you introduce acyl group here, what happens to this? From amine NH2 groups we get NHCOCH3. Now what's happened? This is called bromination. So if you want to do nitration, you need nitrating mixture, HNO3 concentrated and H2SO4 concentrated. You will get these groups. This is electrophile. So when amine is made to react with this, you will get nitro group in ortho, meta and para. So as earlier, we will make acylation, acyl group, enter acyl group in hydrogen group, replace one hydrogen by this one, and in this way. Now for nitration of aniline, again we will use nitrating mixture which is known to you earlier. Both sulfuric acid and nitric acid is like this. You will get NO2 out of this mixture, and you will get one is like this, other is this, and it is very less, and that type of reaction is called terreoxidation. Now again, if you want to get Pyrronitrene as a major product, again we need to protect this group. So we will apply the earlier concept in combination. Am I right? So what happens here is the same as earlier. So activity of these groups as explained earlier is reduced, and now if you use this mixture H2SO4 and will get as a major, and on treating with this TAZ you will get nitro as major. So these are very two things to get due to the activity of this group. This activates the benzene ring. It is impossible to get maximum of any one product. So that's why we need to protect this group either in combination or in nitration by this method, and we will get the desired product. Now let us come to sulfonation. In first year you have got this term sulfonation. Sulfonation means from sulfuric acid. Sulfonation, concentrated H2SO4, SO4, then there is a very important thing comes here. Very often asked in entrance exam, deuterium. What is deuterium? Is the same molecule plus and minus. Once it is deprotonated, it is protonated. Again, it is deprotonated, it is protonated. So when these two are in equilibrium, these ions are called deuterium. This undergo this structure, resonating structures, and here we distantly see that lone pair comes here. So the lone pair of this amine is involved here, and that's why, because of non-availability of this lone pair, the activity of NH2 groups deactivated to some extent, and at this stage we get this. And also the same things occurs if you want to introduce nitro group here. This is minus and this is plus. So since it is base, that one get into this one. Am I right? And you give heat. So now, what is the explanation of parasulfonic group, parasulfonic amine? Because it is not easily desulfonated. Hence, maximum of parasubstance is found. And number two, if it is in ortho position, there is chances of intramolecular of hydrogen bonding, so this is thermodynamically not favored. That's why para compound is major. Now let us come to left out name reaction. One is Senmaya, amine, nitrous acid, NaNO2 plus HCl, benzene diazonium chloride, chlorobenzene, bromobenzene. Mind that chlorine of this has arrived from this one, not from this. Cyanobenzene, these type of reactions are from Senmaya reaction, and if it is Gatterman reaction, so just you do one thing, the same thing here, you use copper HCl, you will get chloro. If you use copper HBr, you will get bromo. This is Gatterman. Now what about Balch-Siemens reaction? This is for chlorobenzene. Benzene diazonium chloride, as above we have produced. Boric acid, chlorobenzene. Now benzene diazonium chloride, what are it? What? Phenol, benzene diazonium chloride, orthophosphoric acid, you will get this. You will get iodobenzene, So you will get this. I think this question has appeared in NEET. I'm not sure. And another important reaction is benzene diazonium chloride, HBF4 fluoroboric acid. You will get nitrobenzene. These are all type of the reactions which very often we get from benzene diazonium chloride. So next reaction is C6H5 COClH aniline, sodium hydroxide aqueous. You will get Scott-Baumann reaction, probably NEET 2021. Name reaction was not given. The reactants with these reagents are given. You are asked to name the reaction, what type of the reaction it is. This is all about the reactions of amine. The scheme of my teaching is, after completion of this organic chapters, I will in second place I will start one class in very short time. I will revise it with 15 minutes or 20 minutes. Then I will start solution of all papers of competitive exam, and in the fourth place I will start live session for doubt clearing. So you please go on with the materials which I give, and hope you will find very easy to understand. In my next class I will start aldehyde. Thank you very much.